Hi and welcome to today's session on the 3D Pythagoras theorem. So what I'm going to be doing is using Pythagoras theorem but now within 3D shapes, where we're going to be concentrating on cuboids and on pyramids. So here we've got a cuboid of height 8 centimeters, of a width of 7 centimeters and a depth of 5 centimeters. We could actually use what we've got here to calculate the length or the distance that E is to C. Because if I was to join A and C up here, you can now see that we've actually created a right angle triangle where AEC or CE is our hypotenuse because it's opposite our right angle just here. It's the longest length within that right angle triangle. Now to calculate this, what we're actually going to need to do is calculate the length of AC. And to do that, we are going to use Pythagoras theorem. So I'm going to use Pythagoras theorem twice. So we're going to calculate the length of AC using AC squared plus AB squared plus BC squared. So 5 squared plus 7 squared equals 25 plus 49 equals 74. Now I could square root both of these sides and find out the length of AC, but because I'm going to be using Pythagoras theorem again for this, I'm just going to plug in my value for AC squared into this. So I'm going to have CE squared equals AE squared plus AC squared. And of course, we already know that this will be 74. So CE squared equals A squared plus 74, which equals 64 plus 74, which equals 138. So that means I'm going to be now square rooting both sides, which is going to give me a value of 11.75 centimeters to 2 decimal places. That's using Pythagoras theorem twice. But we could also get away with only using Pythagoras theorem once, but an extended version of it. So let's call this this length just here that we calculated E, which is our distance here. So E squared equals A squared plus B squared, which is exactly what we used in the previous. And D squared equals E squared, which is this length here, plus C squared. So if I was now to substitute this into this, D squared equals A squared plus B squared plus C squared. So if I was to substitute all of these values in, here I've gone and use just a slightly different formula, where my D is going to equal the square root of my A squared plus B squared plus C squared, because it just means at the end you haven't got to square root both sides. So substituting these in, here we've got 8 squared plus 5 squared plus 7 squared, which equals 64 plus 25 plus 49, which equals 138 square root of, which again equals 11.75 centimeters to 2 decimal places. This is the exact same answer as what we got previously by using Pythagoras twice, in which case we know that this works. So anytime that you see your cuboid, if you wanted a quicker way of doing this, and you've got the height, length and depth of this, you could use this formula to speed things up a bit more. With pyramids, this is slightly different, because we could actually calculate between E here, which is the very, very top, and M, which is the midpoint of B and D, and also between A and C. So it's in the very center. If we was to connect the corners, it'll be on the very center of the diagonals. This is a square base pyramid, but of course this would work with a rectangular base pyramid as well. So first of all, we need to find the length of BD, this line going across the diagonal. Applying Pythagoras theorem, I've got 5 squared plus 5 squared, which is going to give me the square of this. So 25 plus 25, so BD squared equals 50, which is this length here. So the square root of this is 7.07 to 2 decimal places. Now, of course, that is the entire length of this line. In which case, we know that this line coming down, reaching this point M, is the midpoint of this line. So to find this, we are going to have to halve our length of BD. So halving that gives me 3.54 to 2 decimal places. And now I'm going to use Pythagoras to find MEM, because I've got the length of the hypotenuse just here. I've now got the length of DM, in which case I can now use Pythagoras to work out what D is going to be. So here, EM squared equals DE squared, because it's hypotenuse, squared minus DM squared. So here we've got 8 squared minus 3.54 squared, which ends up giving us 51.74. And then square root of that, square root of both sides, that gives me 7.17 centimeters to 2 decimal places. And that's just use that information there to work out the height of this pyramid. If you like what you see, please subscribe. Thank you very much for watching.